Jai Hind everyone. So in today's lecture, we will be going to learn about the various CPU scheduling criteria in operating system. The code for this subject is KCS 401. So in this lecture, we will be going to learn about the basic concepts, then various kinds of scheduling criteria, what are the various algorithms that have been used in the scheduling, then various multiple processor scheduling, and then real-time scheduling, and what are the various evaluation criteria of the algorithm. So what is the basic concept? So the basic concept behind the scheduling algorithm is we have to maximize the CPU utilization. Whenever we are doing some kind of job, or we are implementing a kind of a process, or we are giving a process for the execution in the CPU, then the maximum utilization should be there. So that is only obtained by multi-programming. So what we have to do is we have to channelize all these schedulings, or we have to channelize, we have to maintain, we have to balance out these processes so that no other process would occur in a starvation condition. So what are the various kinds of scheduling criteria that we see in these particular algorithms are? Here is like you have to see what would be the CPU burst time, what would be the input output burst time, then what is the kind of the process execution that occurs whenever you are you are actually having a process in the CPU. So what is the CPU cycle, that about what time the CPU has been allocated to that particular process, or about what time the CPU is waiting for the process after completing the input output execution. So basically CPU burst distribution has to be planned in this manner that CPU utilization should be there. Every process would be having CPU with it, and every process would be having a kind of a timestamp that particular process is going to be executed in this amount of time. So there should not be any kind of a starvation condition occurs. So here in this particular section, you will be able to see the alternating sequence of CPUs and input output burst time. So what is burst time? First of all, the burst time is like, this is the completion time. So this is the time that whenever your CPU or your input output devices are having a one-to-one interaction with the process. So whenever you see, like, this is the load, the add store, and the read from the file. So whenever this kind of situation is occurring, it means it is the CPU burst time. So at this time, the CPU is having interaction with the process. So the process is having CPU with it, and whenever your CPU is waiting for the process, that means that particular process is executing a kind of an input output resource. So that is input output burst time. So here this is waiting for the input output, that is input output burst time. Again, when we are having a kind of instructions going on, like store increment, or writing to the file, or reading from the file, or adding something to the database, retrieving something from the database, that is all the process of the CPU burst time. Okay, and whenever you are executing input output values or using input output resources, it means you are having input output burst time. Okay, now the second point that needs to be taken care of is the CPU scheduler. So what is CPU scheduler? Basically, scheduler is what it is going to select from the various processes. It is going to select those processes which actually needs CPU. So it is a kind of a process in which you are selecting the various kinds of processes among all the processes in the memory that are ready for the execution, and the scheduler will be going to allocate the CPU to one of these processes. So how CPU scheduler is going to select those processes? So that is the main purpose here, that we have to see what kind of algorithm, what kind of you can say scheduling criterias would be there whenever you are selecting the process for the CPU. So CPU scheduling decisions that are going to take place is depending upon some of the points. So what are those points? Like you are switching from a running state to the waiting state. So it means the process is running in the CPU, or the kernel is with the process, and again it is switching from running to the waiting state. That means it is going to be executed for the input output resources. Now again running from the ready state, so this is also a kind of a switching, and again switching from waiting to the ready state. So these are the kind of the decisions that needs to be taken care of while execution of a process, and these decisions have taken by your CPU scheduler. So scheduling, CPU scheduling could be preemptive and could be non-preemptive. So preemptive is like you can poke in between the process or the execution of the process. You can actually, you can say, knock, knock, who is there? So you have to what? You have to select the process, you have to execute the process, and in between, you can also preempt the process. There is also a kind of algorithms which are known as non-preemptive. So in that case, whenever the CPU is allocated to a process, it will be switched only after the completion of the process. The CPU would not be, switched in between the running state. So this is known as non-preemptive. So all the other scheduling or the scheduling processes or the scheduling algorithm that we will be going to study as are preemptive and non-preemptive. So here again a term arises, that is dispatcher. So what is dispatcher? So dispatcher is basically a kind of a module that gives control to the CPU and to the process selected by the scheduler by the various kinds of criterias. So basically dispatcher is a kind of a decision taking process in which it is giving the control to the CPU, that you have to do what? You have to switch the context, you have to switch to the user mode, you have to switch to the manual mode, you have to jump from one location to the another, you have to restart the program, you have to halt the program. So all these decisions made by the CPU will be given by the dispatcher. So what is the dispatch latency? So it is the time taken by the dispatcher to stop one process and to start the another process that is running in the CPU. So that is the dispatch latency. Now, what are the various scheduling criteria? So whenever we talk about the scheduling algorithms, there are certain criteria that we take care of. So what are those criteria? So first one is your CPU utilization. Obviously, we have to keep our CPU busy. That should not be idle. So we have to take care what is the basic utilization that we have implemented with the CPU. Are we utilizing our CPU as at most? So what we have to see, this is the first criteria, CPU utilization. The second criteria would be throughput. Now what is throughput? It is the process to complete the all over the execution that has been allocated to the CPU. So what we have to see at what instant of time my CPU is executing, and what is the actual time taken by this CPU whenever it is executing the process. So throughput is a kind of a processes, or it is known as the average of the processes that needs to be completed in their execution time, and you have to calculate per unit amount of execution. Like if I am saying the timestamp would be 1 second, so in 1 second how much execution of that process has been done. So that is the throughput. Okay, now what is turnaround time? So turnaround time is the amount of time that has been taken by the process to get complete. So it is like, it could have preemption, it could have non-preemption, it could jump from one point to the another point. So you have to see what is the overall point, what is the actual time taken by the CPU to complete a process. completely. So you have to see, if you are starting from 0 or you are starting from 10, what is the maximum time that has been taken by the CPU to complete a process? That is the turnaround time. Now, what is the waiting time? So waiting time is, again, as per the name says, that a process is waiting for that allocation, or the CPU allocation. So the amount of time a process that has been waiting in the ready queue is known as waiting time. Now again, the response time. So response time is what? It is the amount of the time that has been taken by the process whenever a request comes and that has been submitted until the first response is being produced. So that is the response time, that CPU is responding to the process. So in what amount of time the CPU is responding. Okay, so that is the response time. So these are the some of the criteria that needs to be taken care of while implementing any kind of algorithm. Now these are the optimization criterias. So what is the optimization criterias? Like, first of all, definitely maximum CPU utilization. So our CPU should be maximum utilized. The second one is maximum throughput. So my throughput should be maximized. My turnaround time should be minimized, because turnaround time is what? It is the actual time that is being taken by the process to get completed. So that should be minimized. Now I should be having minimum waiting time. My process should not wait for a longer time. And minimum response time. So my response time is also minimum, because this is the time the CPU is being allocated, or the time the CPU is responding to the process. So these are the optimization criteria that we see whenever we are implementing the scheduling algorithms. So first scheduling algorithm is first come first serve. So what happens in the first come first serve is, as per the name suggests, whichever the process is coming first, that process will be given CPU. So whatsoever is the priority, it doesn't make any sense here. So in first come first serve, the processes are coming on their arrival time, and based on their arrival time, they have been allocated with the CPU. So here in this example, you can see there are the three processes, P1, P2 and P3. The burst time has been corresponding written over here. Okay, 24, 3, 3. So what we have to do, we have to prepare a Gantt chart. So what is Gantt chart? Actually, we are preparing a kind of a chart by which we can see which process is executing first. So in this Gantt chart, because this is the first come first serve process, so here the first arrival process is P1. Okay, now the first arrival process P1, the P1 will be executed first. So it will be starting from 0. So the response time for the P1 is 0, and it will be going to execute it up to 24, because the burst time is 24 for the process P1. Now what happens after that? The CPU will be allocated to process P2. So P2 will be having a burst time of 3 units. Then again, it will be going to execute it for 24 plus 3, that is 27. So P2 will be going to execute it up to 27. But the response time for P2 is 24, because P2 has been allocated at the timestamp of 24. Okay. Now, next, P3. So P3 here again, the burst time is 3, going to be executed for 3 more units, that is 27 plus 3, that is 30. So waiting time, if I have to calculate the waiting time, so P1 will be going to be, P1 will be having a waiting time of 0, because it has been allocated first. Then P2 is going to have a waiting time of 24, because it has been allocated at 24 unit, and P3 will be having 27. Now the average waiting time for this is, you have to add all these and then you have to divide by the number of processes. So 0 plus 24 plus 27 divided by 3 will be equals to 17. So 17 is the average waiting time for all the processes for the CPU execution. Now suppose that is not the order of the arrival, the order of arrival change. Then what happens? Suppose the order of arrival is P2, P3, P1. So this is, this is the order of arrival. See, P2 is coming at first, then what then? P3, P3 at second, and P1 at third. So now this is the order of the arrival. So if I have to prepare a Gantt chart here, what happens? The first one is P2. So execution will happen for the P2 first, then P2. The response time for the P2 will be 0 because that is the first process, and the execution will go up to 3 units. Then after that, okay, P2 is done. After that, at the second arrival, that is P3. So the P3 will be allocated CPU. It will go up to again 3 units. So that is your 3 plus 3, 6. And then at last, you will be having P1. So P1, and the burst time is 24. So 24 plus 6, that is 30. Okay. So here you can see, this is it. 0, 3, 6, 30. Okay. Now P2, P3 and P1. So this is the order of the Gantt chart. Now this is the order of the execution of the your processes among CPU. Now what is the waiting time for P1? Now the waiting time changes for every processes. So waiting time for P1 is, previously as per the order, P1 will be having a waiting time of 0. Now the P1 is having a waiting time of 6 units. Again, P2 will be having a waiting time of 0. P3 will be having a waiting time of 3. So the average waiting time, if you're going to calculate, that will come up 3. Previously, it was 17. So you can see the difference. By just changing the sequence, we actually have a minimum waiting time, which is much, much better than the previous case. Now, here comes the situation, convoy effect. Now, what is convoy effect? What happens is, if you are having a larger process at the starting of the execution, so your smaller projects or your smaller processes will be going to wait until the execution is over for the larger processes. So it happens that at the starting of the project, you are having, the project or the process which is having a large amount of burst time. Suppose this is the execution arrival. Okay, so this is the process arrival. So P1 will be having around, you can say, 60 minutes. P2 will be having around, you can say, 0.5 minute. P3 will be having around 1 minute. So this is the burst time. So what happens in this case? Your P2 and P3 will be going to wait for 1 hour at least. So this is the convoy effect, that your smaller processes will be going to wait for a larger time, not even matching to their burst time. So this is the basic, or you can say the disadvantage, the very big disadvantage in first come, first serve scheduling. Now the second algorithm is shortest job first, SJR, or you can say shortest job remaining algorithm. So what happens in shortest job? This is also same as your FCFS, and yes, one thing is FCFS is non-preemptive, as you see, because there is no preemption in between the execution of the process, hence that is non-preemptive. Again, shortest job remaining algorithm is non-preemptive. So what happens is, you can see in FCFS, there is a kind of, a problem, convoy effect, that has been eliminated in SGR. How? Let's see. There is a process P1, P2, P3 and P4, and everyone is having their arrival time as well. Okay, and also the burst time. This is the burst time. It should be written over here. Okay. So what happens is, whenever you are having their burst time and the arrival time, your process is going to check whether the next process that is need to be allocated to the CPU should be of smaller burst time or not. See, At the 0.0 arrival time, you are having P1 with you. So P1 will be going to execute up to what? Up to 7. Why? Because this is non-preemptive. So once the CPU has been allocated, it has been allocated up until the last execution. So 0 to 7, P1 is going to be executed in CPU. Now what? At 2, at 4, at 6, you are having P2, P3 and P4. Your CPU execution goes up to 7. So all these processes will come up. Okay, now the CPU scheduler will select which process needs to be executed. So we have to see which is the smaller burst time among all these processes. So we are saying P2, we are saying P3, we are saying P4, 4, 1, 4. So P2 and P4 are also having similar burst time. So there is no any kind of effect that will be going to happen. P3 is having a burst time of 1 unit. So P3 will be executed first and up to 8. Again, as per the arrival time, you are going to allocate the CPU. So P2 has been come up first, after that P4. So P2 will be executed first and P4. Now if you calculate the average waiting time, that is 0 plus 6 plus 3 plus 7 divided by 4, that will be equals to 4. So here the average waiting time will be 4. Okay. Now there is another kind of algorithm which is preemptive. So in SJF we have seen non-preemptive and now we are going to see preemptive. So what happens if you are having preemptive algorithm with you? So whenever the process is coming at that particular instant of time, you are actually going to check what is the burst time of that particular process. If it is lower than the current process, then CPU switching will take place or context switching will take place. So what happens is P1 executing at 0.0 having a burst time of 7. So it will be going to execute from 0 to 2. Why 2? Because at the arrival time of 2, you are having process P2 with you. So now CPU will be checking whether that particular process is having a lesser burst time than the current process. So yes, it is having 4, which is much lesser because up to 2, the P1 has been executed. So 7 minus 2, that is equals to 5. And 4 is lesser than 5. Hence, the allocation will goes to P2. Now P2 will be going to execute up to 4 because at 4 you will be having P3. So 4 minus 2, that is equals to 2. So at this point of time, P2 will be having a 2 timestamp remaining for the execution, and P3 arrived at 4 will be having a burst of 1, which is again greater than 1. Hence, the allocation will jump to P3. Oh, sorry, allocation will jump to P3. Up to what? Up to 5, because at one instant of time, it will be going to be completed. After that, at 5, you are having P3 and P4 with you. Now what happens is P3 has been completed, so this is no need to see. Now at point of 5, you will be having P4 with you as well as remaining P1 as well as remaining P2. So this is remaining P1, this is remaining P2. Now which one is having the lesser amount of time? So that is P2. So the context switch will again happen for the process P2 up to what? Up to 7. So this needs to be completed in one go. Then after that P2, your execution will jump to P4 because P4 will be having execution of 4 timestamp and P1 is having an execution of 5 timestamp. So 7 to 11 for the P4 and then for the P1. Okay, so average waiting time will be again 3. So this is the preemptive SJF. The previous one was non-preemptive SJF. Okay. The rest of the algorithm we will be going to see in the upcoming videos. Thank you.